Okay, you guys, so we're getting ready for lesson 4.2, our second set of exponent properties. Remember back in the first one in lesson 1, we did when you have a multiplication problem, you add the exponents. And when you have a power to a power, you multiply the exponents, like distributing. So we're going to add to that today a couple more properties here. And then at the end, we're going to start putting them all together. And then we'll mix even more in when we do lesson 3. Okay. So the first part here that we need to talk about is when we had multiplying, we added exponents. So for this one, we're talking about dividing, which means we're doing the opposite. So we're going to subtract the exponents. This comes from having them top to bottom, and then if they have, of course, the same base, like we talked about with the multiplication. So in this part, we're going to do division, right? And division equals subtracting the exponents from top to bottom. Again, they have to have the exact same base. So like if it's x here, it has to be x here in order to subtract the exponents from each other, all right? So I'm going to just put here a little reminder. It's top minus bottom every single time, kind of like a regular subtraction problem, and it has to have the same base. Okay, and just like in our other problems, if we had something that was like, let's say if it was 3x to the 5th times 4x squared, we had coefficients out here, and it's a regular multiplication problem, which means you go ahead and multiply, and then we would have added our exponents. So if we have in a division problem, we have coefficients that are in the problem, then we have to actually divide them like we would normally, okay? So here, we've got x to the 5th over x to the 3rd, which means that you're actually subtracting those two. So we've got x to the 5 minus 3, which leaves us with x squared, okay? Just to kind of show you guys what this actually means as far as an explanation for these two. If you had x to the 5th, that would be like x times x times x, x times x times x divided by x times x times x. So there's 5 up here, there's 3 below, and we know that when there's the same thing over top and bottom, they would divide and cancel. So this would be a 1, this would be a 1, this would be a 1, which leaves you with 2 x's, which is x squared. So just so you kind of understand where this comes from, okay? Same thing for the next one. So we've got k to the 8th over k to the 3rd, which gives me k to the 8 minus 3, which leaves me with k to the 5th. Okay, scrolling down a bit. Now, this is one of our special cases, so pay close attention to this, all right? This is going to be our 0 power rule happening here. So if you look here and we have x to the 3rd minus 3, this gives you x to the 0 power. Well, x to the 0 power always equals 1. All right, now there's no x, nothing happens, but the answer is going to be a 1 every time something is to the 0 power. So big star here. This is our 0 property. Okay, so anything, whether it's a number or a variable, anything to the 0 power equals 1. Anything. So 5 to the 0 power equals 1. Negative 82 to the 0 power equals 1. X to the 0 power equals 1. So anything to the 0 power. All right, so moving on. Now we've got adding in here another variable. So again, if it's like bases, that's when we actually subtract. So A's and A's go together. I've got a to the 6 minus 2. B's would be b to the 4 minus 3. So 6 minus 2 gives me 4. b is 4 minus 3, which is 1, and we don't need an exponent for the 1, so this would be my answer. A to the 4th b. Okay? Scrolling down, getting a little bit more involved. Now I actually have that coefficient out in front that I was talking about, and we have 3 variables. So if we look at just the 6 over 2, 6 divided by 2, because it's a division problem, would give me 3, right? And then I'm going to look at bases that are the same. So x is here. 4 minus 3 would just give me 1. Y's would be 5 minus 5, which would be 0. Okay, so I'm not going to write down y to the 0 because it just stands for a 1. So basically, these are like canceling out. It's just a 1. And if I put in here times 1, that's just going to still be 3. So it doesn't do any good for us to write anything of that down, okay? The last one is 10. On the bottom, we have a 1. So this would be z to the 9th. Okay? So I'm just going to write this out to the side. We took 6 divided by 2 and got our 3. We took x to the 4 minus 3 and got x to the 1st, or x, right? We took y to the 5 minus 5 and got y to the 0, which equals 1, so it just cancels. And then z to the 10th minus z to the 1st equals z to the 9th. And that's where I got 3x z to the 9th. All right, just a little explanation for later in case you need it. Okay, same thing here, coefficients, 14 divided by 7. So I'll just do this as we go. 14 divided by 7 is going to give me 2. My a's would have a 1 here, so a to the 8 minus 1 equals a to the 7th. B again has a 1, so b to the 2nd minus 1 equals b to the 1st, or just b. And then c to the 7 minus 7 is c to the 0, which would also be a 1. So it's like it cancels out. And then here's our answer put all together. 2, a to the 7th, b. Okay, not too difficult. Now, here's where it starts to come together, okay? We are going to now put together the properties that we learned in the first lesson with the properties in this lesson and have one whole type of problem here, okay? So I'm going to switch colors. Let's do a green, or no, let's do a pink. How about that? So for this one, if you kind of pretend like we have to do things in order of operations, right? So we would have to be able to take these problems and do whatever's on the top, whatever's on the bottom, and then kind of put the two together after we're done. So I'm going to take this guy and distribute first to both of these. Remember, it multiplies when it's a power to a power. So I would have 3 squared x to the 10th over 27x to the 3rd. Now, I can still take this and solve this little part, right? So this would be 9x to the 10th over 27x to the 3rd. Now, I can't divide 9 by 27 because I would get a decimal, but I can simplify it as if it were a fraction, which would be 1 over 3, right? 9 goes into 27 3 times. So you kind of have to think about these as, yes, if you can divide, that's great. If you can't, it's still a fraction, so you need to simplify when needed, okay? So this would be my 1/3, and then 10 minus 3 would be x to the 7th. And that's going to go on top because it is a positive number. So it's going to be like a normal x to the 7th. So really, you could just put x to the 7th, or you could have 1/3 x to the 7th out top, whatever you wanted to do. Okay? Or out to the side, sorry. All right. Very good. Here we go. Next one. So again, at the top, I'm going to distribute the 3 to the 2, the a squared, and the b to the 4th. This is going to give me 8. 2 to the 3rd is 8. Then I have to multiply. So a to the 6th, b to the 12th, and it's over 4, a to the 3rd, b to the 7th. Okay, coefficients first. So 8 divided by 4 here gives me 2. 6 minus 3 for my a's gives me a to the 3rd. And 12 minus 7 gives me b to the 5th. And I'm all done. Okay, let's flip it over. Go to the back at the top. Same thing, just more of combining those same types of properties all together. Okay, a little bit more complex. So on these, you always have to remember we just need to stay in a particular order. So we're always going to do that top part first, then do the bottom as combined. Okay, so this doesn't have any distributing. So this would be like having that dot in the middle, but it's parentheses instead, which means we need to multiply coefficients, right? And then we need to add exponents because it's a multiplication property. Oh, sorry. Oopsies. So because it's a multiplication problem, not property. So 9 times 4 gives me 36. And now I'm adding exponents. This is a 1 and this is a 1. So I have x to the 6th, y to the 7th, over 6x squared y to the 4th. Right? Now I'm going to divide. 36 divided by 6 is 6. And it's division, so I'm subtracting. So I've got x to the 4th, y to the 3rd. Okay. Next one over here, we've got a few things happening. Now we're basically got every property we've learned happening in one problem. So this 2 is on the outside of the parentheses, which means that it's going to be distributed first because we multiply first. So I'm going to have 10 squared, which is 100, and then a squared, b squared for that part. I didn't touch anything on the other side, so this is like a dot here, remember, it's multiply. So I'm going to put times 2a to the 4th, b to the 3rd. I didn't change anything about this because there's nothing to distribute. And it's all over 4a to the 5th, b. Okay, now, still all things on the top, so I got to finish that out first. 100 is my coefficient over here, and 2 is over here. So that's going to give me 200. 100 times 2. Now I'm adding coefficients here, or exponents here. So a to the 6th, b to the 5th. That gives me my finish for my top, and I've got 4a to the 5th, b on the bottom. Now let's simplify. 200 divided by 4 gives me 50. 6 minus 5 is 1, so that just leaves me with a. And 5 minus 1 is b to the 4th. And there's your answer. So again, simplifying one step at a time to make sure that you have the answer for the top and then the bottom, and then put the two together. Okay? Now, this one's going to be different because we've got a top to solve, a bottom to solve, and then we have this extra spot out here that we need to worry about afterwards. Okay? So, same type of thing. Let's do the top first and do one step at a time. So I have this 2 that's being distributed to -6, x and y. So -6 squared would be +36. Then I have x to the 8th, y to the 12th. Remember, you're multiplying when you're distributing. Over, on the bottom, I'm going to distribute this 2 all the way through. So -3 squared would be 9. And then I have x to the 6th, y to the 10th, times 7x squared, y squared. Because I didn't touch this part over here. Now, let's simplify the left side. This whole section here needs to go first. So 36 divided by 9 gives me 4. Subtract because it's division. So x to the 2nd, y to the 2nd, or squared, right? Times, this part over here hasn't changed, so 7x squared, y squared. Now we're back to that very first power we did, or property we did the very first day. So multiplication means I'm going to multiply coefficients. That's 28. And then I'm adding exponents. So x to the fourth, y to the fourth. All right, you're doing great. Last one here. Last one. So this last one, again, pulls in all of these and even shows us something a little bit different. If you notice now, this 2 on the outside is on the outside of this entire set of parentheses, which means this guy has to go and be distributed to the top of this and the bottom down here. Okay, so let's get that taken care of first. We've got 4 squared and then x to the 14th over 6 squared x squared, right? Times 27x to the 4th. I haven't even touched that part yet. Now, we can go ahead and do this 4 squared and 6 squared. Like, we know what those answers are. So this is going to be 16x to the 14th over 36x squared, right? Still times 27x to the 4th. Okay, so now I can still do this side. Well, I can't take 16 divided by 36 without getting a decimal. So again, it's like a fraction. We're going to simplify it. Okay, 4 goes into both of these, so this would be 4/9. And then 14 minus 2 would give me x to the 12th times 27x to the 4th. Okay, just like normal, these two are going to be multiplied by each other. So 4/9 times 27 equals 12. And then multiplication means we add. So 12 plus 4 is x to the 16th. Okay, do one part at a time. You guys have a set of 4 down here that I want you to do on your own. They look complicated, but it's one step at a time, like we talked about. Do the top part all the way through and then do the bottom if there's more than one step. Let me know if you have questions and we'll check them in class. Good job, you guys.